Good morning, everyone. Today we are moving towards the new topic, that is the introduction of sequential circuit. Before going towards the contents of today's topic, we know the what is the basic concept of sequential circuit. Otherwise, what is the meaning of sequential circuit? Sequential circuit, otherwise we are calling sequential logic. It is one of the automata theory of sequential logic. Is a type of one of the logic circuit whose output depends not only on the present value of its input signals but on the sequence of past inputs, the input history as well. This is the contrast to combinational logic whose output is function of only the present input. Sequential logic has state, otherwise we are calling memory, while combinational logic does not exist. Sequential logic is used to construct finite state machines, basic building block in all digital circuitry. A familiar example of device with sequential logic is television set with channel up and channel down buttons. Pressing the up button gives the television an input telling it to switch to the next channel above the one it is currently receiving. If the television is on channel, when pressing up switch it to receive channel, and however if the television in on channel, pressing up switches it to the channel. In digital sequential logic, circuits are divided into some parts, that is the synchronous and asynchronous types. In synchronous sequential circuit, the state of the device changes only at discrete times in response to clock signal. In asynchronous circuits, the state of the device can change at any time in response to changing inputs. This is the all about the basic information about the sequential circuits. In digital circuits as well as switching circuits, there are types, the combinational circuits and sequential circuits. Already we seen related to sequential circuits. Now we already learned the first chapter related to combinational circuit. Combinational circuits are circuits made up of different types of logic gates. A logic gate is a basic building block of any electronic circuit. The output of the combinational circuit depends on the values at the input at any given time. The circuits do not make use of any memory or storage device. Here is the given some examples, that is the adder, subtractor, encoder, mux, demux, magnitude comparator. Already we learn about that different types, that is an adder adds two signal digit binary number and forms the foundation for all addition operations in computing. If we have two single binary digits A and B, then half adder adds them with circuit carrying two outputs, sum and the carry. Same for the in adder, there are different types: half adder, full adder. In subtractor there is the half subtractor, full subtractor, encoder related to correlated to mux, as well as decoder, demux, and magnitude comparator. This is related to comes under the combination circuit. And sequential circuit, there was a latch, flip flop, shift register, and counters. Now, so what is the latch? In electronics, a flip-flop or a latch is a circuit that has two stable states, and it can be used to store state information. That is also called as bistable multivibrator. The circuit can be made to change state by signals applied to one or more control inputs, and will have one or two outputs. It is the basic storage element in sequential logic, as well as in flip-flop and latches are fundamental building blocks of digital electronics. Systems will be used in computers, communications, and many other types of systems. Same flip-flop and latches are used as an data storage elements. Flip-flop is a device which stores a single bit, that is the binary digit of data. Flip-flop can be either level triggered, that is the asynchronous, transparent, as well as we are calling as opaque. The term flip-flop has an historical record mm, to both level triggered and edge triggered circuits. In sequential circuit, there is another one type, that is the examples, that is the shift register. In digital circuits, shift register is a cascaded of flip-flops, and it will be sharing the same clock in which the output of each flip-flop is connected to the data input of the next flip-flop in the chain, and it will be resulting in circuit that shifts by one position the bit array stored in. Same about the another one example, that is the counter. In digital circuits as well as in computing, counter is a device which stores the number as well as particular event or process has occurred, and it will be relationship with the clock. The most common type of sequential digital logic circuit is the that is the counter. Here will be given in detail, that is combinational circuits are defined as an time independent circuits which do not depends upon the some previous states as well as previous input to generate any output. It is the called as a combinational circuit. The given inputs we get the output by using of combinational circuit. Here is the inputs we got the output. Already we learn in mux demux. In that mux demux we are using the different select lines. In sequential circuits we using, it will be depends on the clock cycles as well as depends on the present as well as past inputs. Whatever the present input as well as whatever the past input, it will be depends on the sequential circuits. It requires on the sequential as well as it requires the memory limit for the sequential circuit, because whatever the next state will be generated as an internal input as a memory limit, and it is generates the output will be considered as an input of an combinational circuit. This is about sequential circuit. Here is the given comparison of combinational and sequential circuit. Combinational circuit and sequential circuit. And the combinational circuit depends only upon the present input and there is a no need for any feedback for input purpose as well as an output purpose. Memory element, it is the not required for the combinational circuit. As compared to combinational circuit with sequential circuit, the output will be depends upon the both present as well as previous state. So memory element is required to save the whatever the input data or previous state data for the feedback purpose. And it is very easier to design as well as very easy to handle in combinational circuit. In sequential circuit, it is not easier to design, and it is critical handling as compared to combinational circuit. Clock signals are not required in the combinational circuit because it is only dependent on the time, and here is the clock signal will be required because here we using some flip-flops, counter shift registers, and it is dependent on time as well as in clock and as well as need to triggering. Building blocks are only for using, that is the logic gates. Here building blocks are using as in flip-flops. This is then combinational circuit, very faster logic circuit, and these circuit are very slower circuit as compared to combinational circuit. Combinational circuits are mainly used as an arithmetic as well as Boolean operations. In sequential circuits, is mainly used for the storing data. In element blocks in combinational circuit, elementary building blocks for combinational circuit are logic gates. In sequential circuits, it is used as an flip-flop purpose. Here is the classification of combinational circuit. Combinational circuit, there is three types. On the arithmetic and logical functions. Second one, data transmission. Third one, code conversion. In arithmetic and logical functions, there are types, a number of types, that is the address. In address, there are different types: half adder, full adder. In subtractor, same: half subtractor, full subtractor. Comparators, 2-bit, 4-bit magnetic comparators. That is the program logic devices, that is the PLDs. In data transmission means the n number of inputs we get the single output, otherwise uh, single input n number of output, that is the multiplexer, demultiplexer. In the multiplexer, there is the different types also, encoders as well as decoders. In code converter already we learn, that is the different types of code converter: binary to gray to binary, and BCD 7 segment. That all the types will becomes under the code converters. That is the classification of combinational circuit. The classification of sequential circuits, that is the already we learn about the combinational of, sorry, classification of combinational circuits. Types of sequential circuits. Sequential circuits can be event as well as drive as well as clock driven as well as pulse driven. Here also the two types of sequential circuits, that is the synchronous and asynchronous. The synchronous types use pulse or level inputs and clock input to drive the circuit with restrictions on pulse width and circuit propagation. And asynchronous sequential circuits, here is another one which are controlled by a clock, are called as an sequential synchronous sequential circuit. And these circuits are very active only when clock signal is applied. And asynchronous sequential circuit do not use clock signal as an synchronous circuits, which are not controlled by a clock, are that is called as synchronous sequential circuits. The comparison it will be given here: synchronous circuit and asynchronous circuits. In synchronous circuits, the memory elements are, that is the clocked flip flop, and in asynchronous circuits, the memory elements are not clocked flip flop. In synchronous circuit, the change in input signals can affect the memory elements upon some activation of clock signal. In asynchronous circuits, change in input signals can affect the memory elements at any instant of time. Synchronous circuit is very easier to design and it is more difficult to design. In synchronous sequential circuit, the memory unit which is being get used for governance is clocked flip flop. Here is already mentioned. Complexity, it is easy to design. In other hand, synchronous, the presence of feedback among the logic gates causes instability, that is the issues making the design. In examples of synchronous circuit, that is the it is used in counters, in different shift registers, in memory element units. In other hand, asynchronous circuits are used in low power as well as high speed operations such as simple microprocessors, DSP, that is the digital signal processing units, and in some communication systems for email applications, internet access and networking. Here is the given basic details related to flip flop, and that will be seen in the next lecture. Before ending of today's lectures, we check the what we learned today's in lectures. That is like introduction of sequential circuit, the what is the types of digital circuit, that is the combinational circuit and sequential circuits. Already we learn in details combinational circuits with each examples in details. Now we time towards that is the sequential circuits with details of latch, flip flop, shift register and counters. We see the definition related to combinational circuit with basic block diagrams. Same for the sequential circuit, it requires memory elements with present state as well as previous output. We already seen the combinational circuit and sequential circuits comparisons. Then classification of combinational circuit, already we covered that all the parts in the previous unit. Classification of sequential circuit, synchronous and asynchronous. We seen the details where will be clock applied, when not clock applied, what will be happens. We already seen in types of sequential circuit and comparison of synchronous and asynchronous. This is the basic introduction of sequential circuit and combinational circuit. Now we are moving towards the details of sequential circuit, that is the flip flop, latch, shift register and counters. That will we start in next lecture. We stop here. Thank you.